8355. How is it determined in a master cylinder brake system that all of the air has been purged from the system? A. By operating a hydraulic unit and watching the system pressure gauge for smooth, full-scale deflection. B. By depressing the brake and noting that the brake is firm and not spongy. C. By measuring the amount of fluid returned to the master cylinder upon brake release. The correct answer is B. When air is present in the brake lines, it can cause a spongy feeling in the brake pedal and reduce the effectiveness of the brakes. Bleeding the brakes removes the air from the lines, and once all of the air has been purged, the brake pedal should feel firm when depressed. 8356. The left brake is dragging excessively on an airplane on which no recent brake service work has been performed. The most probable cause is A. Foreign particles stuck in the master cylinder compensating port. B. Excessively worn brake linings. C. Low fluid supply in the brake system reservoir. The correct answer is A. To ensure proper functioning of the brake system, it is important for the compensating port in a brake master cylinder to remain open. The compensating port serves as a vent, allowing fluid in the brake line to flow back to the reservoir when pressure is released from the brake pedal. If the compensating port becomes blocked or plugged with foreign matter, the fluid cannot escape, resulting in a condition known as brake drag. Brake drag occurs when the brake pads or shoes do not fully disengage from the rotors or drums, causing them to continue exerting friction and resulting in excessive wear, reduced fuel efficiency, and potential overheating of the braking system. Regular inspection and maintenance of the brake system, including checking the compensating port for any blockages, are necessary to ensure proper brake operation and prevent brake drag. 8357. If a brake debooster is used in a hydraulic brake system, its position in the system will be A. Between the pressure manifold of the main hydraulic system and the power brake control valve. B. Between the brake control valve and the brake actuating cylinder. C. In the brake pressure line between the brake pedal and the brake accumulator. The correct answer is B. A brake debooster is a device used to reduce pressure in a hydraulic brake system, which in turn increases the volume of fluid flow to the brake actuating cylinder. It is typically located between the brake control valve and the brake actuating cylinder. The debooster operates by reducing the input pressure from the master cylinder before it reaches the brake actuating cylinder, allowing for smoother and more controlled braking. Placing the debooster in any other position in the hydraulic system would not achieve the desired effect of reducing pressure to the brake actuating cylinder. 8358. The hydraulic packing seals used in a landing gear shock strut are A. Generally designed to be compatible with more than one type of fluid. B. Kept from direct contact with fluid by Teflon or nylon backup rings. C. Used only with a specific type of fluid. The correct answer is C. Hydraulic packing seals used in landing gear shock struts are made of materials that are compatible with a specific type of hydraulic fluid. Using the wrong type of fluid can damage the seals and cause leakage, leading to loss of fluid and possible failure of the shock strut. Therefore, it is important to use the correct type of fluid specified by the manufacturer and avoid mixing different types of fluids. 8359. Lockout deboosters are primarily pressure-reducing valves that A. Allow full debooster piston travel without fluid from the high-pressure side entering the low-pressure chamber. B. Cannot allow full debooster piston travel without fluid from the high-pressure side entering the low-pressure chamber. C. Must be bled separately after brake bleeding has been completed. The correct answer is A. A lockout debooster is a type of debooster used in hydraulic brake systems that provides a constant and reduced pressure to the brakes. It has a piston that separates two chambers, one with high pressure and one with low pressure. When the brakes are applied, The lockout debooster reduces the pressure of the high-pressure chamber and applies it to the low-pressure chamber, which in turn applies a reduced pressure to the brakes. Lockout deboosters are designed to allow full piston travel without fluid from the high-pressure side entering the low-pressure chamber. This is important because if the high-pressure fluid were allowed to enter the low-pressure chamber, it would increase the pressure to the brakes and potentially cause them to lock up, leading to loss of control of the aircraft. Therefore, lockout deboosters are designed to prevent this from happening by allowing only a reduced pressure to be applied to the brakes.